All right, in definition 5.4, we see the logarithm rule for integration. And that just says that the integral of 1 over x dx is equal to the natural log of x plus c. And this is just straightforward. It's just undoing the derivative, right? The derivative of the natural log of x plus c is equal to 1 over x. So therefore, by definition, the integral of 1 over x should be ln of x plus c. And then if we do some type of u substitution, then we'll get that if you have something of the form du dx over u, and you integrate that with respect to x, that should be equal to the integral of 1 over u du by u substitution rules. And of course, that integral will be ln of u plus c. So let's do this. Let's do this in example 511. We'll see what happens when we try to apply these rules. And so we're going to do a little bit of scratch work over here. And hopefully, if you look at this, you ask yourself, what should u be? And it should be the more difficult thing or the more complicated thing, so that when you take the derivative, you get the other piece of the integrand. So if you have x squared plus 1 as your u, then du dx is going to be equal to 2x, or du will be equal to 2x dx. And that's not quite what we have. We have a 4x dx up here, but a little bit of algebra says that you just multiply both sides by 2, and you get that 2 times du is equal to 4x times dx. And now we can substitute the 4x dx with the 2 du. So once again, this is going to be equal to 2 du, because we have an equation saying they're equal. And the u equals x squared gets placed down there, so this is u. So let me write all that down. We have the integral of 4x over x squared plus 1 dx. And if it's simpler, you can think of this as 1 over x squared plus 1 times 4x dx. Those are algebraically equivalent. And so then you can see that this first piece is u, or 1 over u, I should say. Maybe I'll do that in purple. So the first piece is 1 over u, and the second piece is 2 times du. And again, whenever there's a constant in the integrand, I move it out front. So that's 2 times 1 over u du, which is equal to 2 times the natural log of the absolute value of u plus c. And again, the absolute value is there because you don't want to take the natural log of a negative number. And now we should check our work. So this is the final answer. Oh no, it's not the final answer. We need to plug back in for x. So you should plug in, you should have 2 ln of the absolute value of x squared plus 1 plus c. And that is our final answer. And then we should check that this actually worked. So let's take the derivative of 2 ln of x squared plus 1 plus c, and we'll get 2 times 1 over x squared plus 1 times 2x, because that's the derivative of x squared plus 1, which is indeed equal to 4x over x squared plus 1. So our check worked out, because that was exactly what we started with up here, was 4x over x squared plus 1.